I designed my open inverter variant for the Prius inverter and the gearbox, the board that eventually going to have to drive a car. When it came to manufacturing, I made 2 prototype boards. The first one worked straight out of the box. I got my motor spinning on the first attempt. The second one taught me a lesson instead, because working first time is exactly what made me careless with it. Normally, when I power up the board for the first time, I have a routine. Current limited bench supply, so if there is a catastrophic short somewhere, the supply limits the current and hopefully saves the components. And before that, a meter on the main rails, checking for anything that shorted to ground. Board 1 worked, so I skipped all of it and powered the board 2 straight up to see what happened. Good news first, 5 volt fine, minus 5 volt fine, 26 volt fine. 3 out of 4 rails came exactly as they should. The 3.3 rail did not. LED never lit. So I did the thing that I should have done first and measured 3.3 rail to ground, near enough a dead short. Very low resistance, the kind of number you don't want to see on your meter when you're doing this check. Fine, it's almost always a capacitor. Ceramics fell short, everyone knows this. So I picked up most likely one, unsoldered it and measured again. Exactly the same. Okay, diodes also fell short. Off come the diodes, measure again. Exactly the same. At this point, I'm sat there scratching my head with a hot iron in my hand, which is on its own kind of hazard. So I went for slightly unconventional approach. Okay, so the drastic fault requires drastic measures. What I've done, I've soldered ground and I've soldered the red wire to 3.3 volts. I'm planning to connect it to the power supply, inject about 1 volt current limited to about 300 milliamps. And I sprayed alcohol across the board. 1 volt won't hurt anything on that rail. But short doesn't care how much voltage you give it. It will still pull current and it will still get warm. Then you just watch it. And the trick is, if you're not looking for smoke, you're looking for a patch that dries first. Whenever dumping the current is going to evaporate its own little clearing before everything else does. To be thorough, I was going over each component with a fingertip, which is a diagnostic technique with an obvious failure mode. And yes, I found out that too. The patch that dried first was over STM32 chip, which was in engineering terms the worst possible answer. And not because it's expensive, but because it's 64-pin QFP package, and it was about to become the hardest thing on the board to get off. So, being in no hurry whatsoever to desolder a 64-pin chip, I went looking for a better answer, and I found one, or I thought I had. The 3.3 volts regulator IC was also getting warm. That felt like a lead. The regulator output stage has internal paths that will happily conduct in reverse. So the regulator warming up under injection is exactly what's supposed to happen. It's the classic false positive with this method and I fell for it. I removed it anyway, measured again, still shorted. At this point there wasn't much left to argue about. The chip was a culprit and the chip had to come off. This is the part of the repair where you stop being clever and start being patient. Hot air, plenty of it, soldering iron to help where it could. Because one thing you cannot do there is lift a pad. Chip off, meter back on 3.3 volt rail, 212 ohms. This doesn't sound like a triumph, but it is. There is no short. That's just a normal load of everything else that is sitting on that rail. The short left the board together with this chip. Then the confirmation step, and this bit matters. I soldered the regulator, the capacitor and the diode back and measured again, same reading. So all three were fine all along and I'd pulled them for nothing. Now I know the rail is genuinely clean rather than hoping it is. Now the replacement. I had another one of these chips, but it was already soldered onto a different board, so it had to come off that one first. Film over the surrounding components so the hot air doesn't send everything nearby across the workshop. Chip off, chip across. Then flux and more flux than that. Whatever you think is enough, it isn't. Soldered it down and there it was, the repair. This board is from PCBWay, and the reason that matters for this particular video is copper adhesion. How well the pads are actually stuck to the substrate. You don't think about it when you order. You think about it when you're holding hot air gun over a 64-pin chip, because the failure mode is that the pad comes off with the chip. That's it, board gone. Not easily repairable. I took a chip off, put 3 components back, and soldered a new chip onto the same pads. Everyone held, which is the only review of PCB manufacturer that is worth anything. Not what it looks like when it arrives, but whether it survives you. And this one did survive me, I have to say. Links in the description below. Now to the second fault. You'd think that having found a dead short and chased it down to the actual processor, the board and I were square. No, we weren't. Because this board has 2 brains on it. The STM32 runs the inverter, the ESP-S3 runs the web interface, and having fixed the one, I got to spend the next few days on the other. And opposite flavor of the fault too. This 3.3 volt short was dead, obvious and measurable. A short is a short. On this board, the LED here will light up when Wi-Fi is ready. The symptom called start. Leave the board off for 5 or 10 minutes, power it back up, and the ESP doesn't come up at all. No web interface, no Wi-Fi, nothing. Cycle the power straight away and it's fine. Fine all day. Leave it another 10 minutes and it does it again. And that timing is the clue, though it took me a while to get there. First suspect, the enable pin. It has to be high for the chip to run. Put it low and the chip resets. That's its entire job. I checked it, it was fine. Second suspect, the power supply. Scoped it, coming up, also fine. Note the shoulder when STM32 is kicking on. Everything I suspected was about the power, because the symptom looked like power. Board goes on, nothing happens. So I measured the supplies, all of them. Repeatedly. They were all fine every time, which I took as an evidence that I hadn't found the problem, rather than the evidence that the problem wasn't there. Best theory I had was the Wi-Fi radio. It grabs a burst of current at the moment it switches on. So maybe the supply has dipped just for a second and knocked the chip over before it got going. It was a good theory, but it had one fatal flaw that it couldn't survive. Because when the board fails, it draws less current, and that's not a chip that's crashed. A crashed chip tries again and again and again and keeps doing it until you unplug it. Mine was just sitting there quiet, drawing a lower current. That led me to look at the GPIO 0, which is a strapping pin. When the chip wakes up, it looks at that pin, and if it's low, it decides you want to reprogram it. So it goes into bootloader and waits for the code to be uploaded. It would have waited forever as it has no concept of being wrong, which is I envy a bit, I have to say. And on my board, that pin has a capacitor on it and no resistor. Nothing to charge it but a weak pull-up inside the chip, 45 kilo. This resistor limits current a lot, so it takes ages to charge the capacitor. So it's a race. The chip wakes up on a fixed delay. The capacitor charges at its own pace. Whatever the pin says is that exact instance is the answer, and the chip doesn't ask for it again. Power cycle it straight away, and the capacitor still half full from a second ago. Pin reads high, everything's normal. Leave it for 10 minutes and that is flat. Now it has to charge from nothing, while the power supply is still coming up. It doesn't make it. The fix is one resistor. 10 kilo ohms on a boot pin charges the capacitor about 5 times faster, and the pin wins the race comfortably. I soldered it on, it has worked every time I tried. Days of diagnosis resolved by the cheapest component on that board.